Hello and welcome. Today we're going to be looking at some of the unit tests in the Precalculus course. This one is on composite and inverse functions. It's 9 questions, and let's get started. Okay. The following table shows a few inputs and outputs of d of x. So we have x and we have d of x, and we're asked for the value of d of the inverse of d of 5. So how are we going to do this? I'm going to move my picture up a little bit to the top, so that we can see this. Okay, so how are we going to go across doing this? Well, what is an inverse? What do we know about the inverse? Well, we know that d of the inverse of d of anything like x or y or anything is going to equal that same thing. Again, they cancel each other out. Okay, so if we're looking at the inverse of 5, then we essentially are just saying that with 5 here, we want to figure out what this number of d of something equals 5. That's all it is. So d of what is 5? Well, d of 17 right here, that is 5. So the answer to the inverse of d and 5 is 17. Let's move on to our next question. Alright, so function f graphed below is not an invertible function. To which intervals could we restrict the domain of f to make an invertible function? Now the reason it's not an invertible function is because it doesn't follow the horizontal line test, right? That's this line test, right? It doesn't follow that horizontal line test because I hit on more than one point for those lines. Okay, so we want to make sure we only hit once on that. Well, we have our options -8 to -4, from here to here, right? That would work. From 0 to 8, 0 to 8, that also works. Let's scroll down. And then from 1 to 6, from 1 to 6, this much, right? Now, if you notice that the key here is that none of them are spanning both of these quadrants, because that's where the trouble starts, because you get duplicates and stuff. So all 3 of these are going to work, and we can move on to our next question. Okay. Dennis has modeled the following relationships about a party he is planning. So we have a function n, m, and c. We have the input, dollar saved, x, hour spent babysitting, h, number of people invited, p. And the output is n of x, number of people he can invite, m of h, dollar saved, and c of p, cost of the party. So which of the 2 composed functions makes sense in this context? Okay. Let's see. Let's think about which of the composed functions. There's 2 of them that make sense, right? Which one? Well, let us think about this. So let's look at the first one, n of m of h. Alright, so we're essentially taking the dollar saved of the party and putting that in as x. Well, that is what x is, so that makes sense. Okay, now another one is m of n of h. We're taking the hour spent babysitting and putting that in as the dollar saved for the party. Well, that doesn't really make sense. So let's skip that one for now. Then we have n of c of p. Well, we put in p, number of people invited to the party, in for the for c, that gives us cost of the party, and then we're putting that in for dollar saved, and that is number of people Dennis can invite to the party. Well, that kind of goes in circles, you know. But let's skip that one also. And then our last one, c of n of x. Well, we're doing n of x, which gives the number of people he can invite, and that's as p, which is what p is, number of people invited. So that also makes sense. So these 2 are the composite functions. We just matched up this to that to this, and that's how we got those composite functions. Let's keep going. Okay. The graphs of the equations f of x y equals f of x and y equals h of x are shown in the grid below. Which of the following best approximates the value of h of f of -6? Okay, so h of f negative 6, well, f of -6, right, f of -6 is going to be -2. So we then just have h of -2. H of -2 is around 1. So then we just have 1, and we can keep going. Okay, next one, f of x equals 3 times 2 to the x, and h of x equals 2x minus 7. Told to evaluate h of f of 2. Now f of 2 is going to be 3 times 2 to the 2, 3 times 4 is 12. That's just going to be h of 12, which is 24 minus 7, or 17. And we can keep going. F is a finite function whose domain is the letters a to e. The following table lists the output for each input in f's domain. Build a mapping diagram for f by dragging the endpoints of the segments in the graph below so they pair each domain element with its correct range element. So a goes to 2, b goes to 1, c goes to 0, d goes to 1, 1, and then e goes to 2, and that's all of them. So f is not invertible, you see, because for you have, like, say, f of a and f of e both give 2. Now, if you have the inverse of f on 2, do you put a or e? You don't really know, right? It's not a 1-to-1, so you don't know. Since it's not 1-to-1, you can't invert it. So that is our answer. It's non-invertible, and we can keep going. Alright, so we have functions f and h are invertible functions. F of x equals x cubed over 27, and h of x equals 27 times the cubed root of x. And we're trying to answer 2 questions about these functions. So write a simplified expression of h of f of x. Well, f of x, x cubed over 27, and then we put that in for h of x, and we get the cube root of that, which is x over 3. X over 3 times 27 is 9x. 9x. And so they're not inverses because we didn't end up with x, which is what we started with. So they're not inverses. Let's keep going. Alright, so now we have g of x is 8x minus 1 over x plus 4. H of x equals 3x plus 10. And we're trying to get g of h of x. Well, h of x is the 3x plus 10, and then we plug that into the top. We get, let's see, 24x plus the 80 minus the 1, so 79, plus 79, sorry. And then we get that over 3x, whoops, that was a horrible 3. 3x plus 10 plus the 4, 3x plus 14. And our answer is 24x plus 79, oops, let's just put it, 24x plus 79 is 3x plus 14. Okay, and that's our answer. Let's keep going. Last question. F of x equals the square root of x minus 1, and h of x equals x squared plus 5. What is the value of f of h of 2? Well, h of 2 is going to be 4 plus 5, which is 9. F of 9 is going to be the square root of that, which is 3 minus 1, or 2. So this is going to be 2 right here. Now, if we do h of f of 16, that's going to be the square root of that, which is going to be 4 minus 1 is 3. H of 3 is going to be 9 plus 5, or 14. So based on this, it doesn't seem, well, let's see. Does it seem like they're inverses? Well, no, since we didn't always get back what we started with. Sometimes we did, sometimes we didn't, but the times we did just might be a coincidence, because here we didn't get back what we started with. So they're not inverses. Alright, and that is it for this unit test. That is all 9 questions, composite and inverse functions. I hope you learned something from this video or enjoyed it, and I'll see you next time we continue looking at more pre-calculus unit tests. I'll see you then.